Hi, this is example number 4 of chapter 13. The section is 13.4. So we have this 30 kilograms block that is originally in rest and is towed by this motor. It's a series of rollers that the motor is drawing that block with a velocity of 0.44 d squared. So we have the velocity and we want to find the force in the cable, so that tension, and the distance, that S. So we want to find that distance S that it will cover once. Well, we can measure, we can measure the distance from here or from the end of the block, it doesn't matter. So we want to measure that distance after 5 seconds. As usual, we want to apply our equations of motion, right? Force equals mass times acceleration. We want to do our free body diagram of the block or that bar, and then the first thing that we always put is our weight, so we don't forget, is 300 kilograms times the gravity. And then we put our normal force. I don't like to put it in the middle because it usually has to be in the middle because I am applying other forces besides the weight. And we can draw this force. I like to draw it because it's an unknown with a different color. So we know that this is an unknown. And then we have our tension that is also an unknown. And if we want to apply our equations of motion, we draw our free body diagram for the external forces, our kinetic diagram for our inertial forces. So we draw kinetic diagram of the same block, and there that will not move in the vertical direction, so we have to always talk about our system, X and Y. So in the Y direction, I do not have any velocity acceleration. And then I only have my acceleration in x, so it will be m times ax. So we apply our equation for that, and we have that the tension will be equals to the mass and acceleration. This is applying forces in x equals mass x. We do not have any other force because they do not give us any information about the surface, so we should assume that it's smooth, and then we don't have any friction. So since we don't have any friction, the only force in the next direction is our tension. However, that will be very nice if we have the acceleration, but we do not. We are given the velocity. So, but what do we know about the relation between the acceleration and the velocity? We know that the acceleration is the derivative of the velocity respect to time. Since we are given the velocity, we know that the acceleration will be then the derivative over time of 0.4 t squared. That is, the acceleration is equals to 0.8 t. And we want to find that tension for 5 seconds, and we have the expression of that acceleration in terms of time. We can plug that in, so that the acceleration for times equals 5 seconds will be 0.8 times 5. Having that, then we just have that our tension is equals to the mass, which is 300 kilograms, times 0.8 times 5. And that gives us value for the tension equals to 1200 newtons. 4 times equals 5 seconds. So we already found the force in the cable, which is the tension. They want us to find also the distance for t equals 5 seconds. So we know that the distance is related to the velocity as well. So we know that the velocity is the distance over time. So we know that our distance will be equals to the velocity, and we integrate both sides of the equation, and we get that S minus S0 is equals to the velocity, the expression of the velocity, which is the integral of 0.4 d squared dt for t equals 0, which is 0 to 5 seconds. So we get that is 0.4 t cubed over 3 evaluated in 0 and 5 seconds. And we can say that S0 is equal 0, so my initial position is 0, so my final position will be 0.4 times 5 seconds cubed over 3. And if we calculate that, that gives us our distance, which is equals, I have it here, is equals to 16 meters, 16.7 meters. So we calculated also the distance. We calculated our tension with the equations of motion, and we calculated our distance just simply our relations between distance, velocity, and we also used the relation with the acceleration and velocity.